to implement best microservices, to implement best microservice, to implement best microservice, we should follow all best practices or patterns. Okay, all the best practices we should follow here, so that we can able to create the best microservice. Okay, what are all that patterns that we need to consider? Where to start? Which pattern I should understand first? Which pattern I should understand first? Okay, so basically first let's understand monolithic. Okay, so in interviews you will be getting what is monolithic versus microservice. People will ask what is monolithic, what is microservice. Okay, in simple words monolithic will have all the functionality of an application we do implement. In monolithic we do implement all the functionality as modules. As modules we will implement all the features, application features we implement as modules. Okay, we'll implement like a modules. Okay, if you take any e-commerce, right, if you take example any e-commerce, let's understand what monolithic design pattern, monolithic architecture versus microservice. Okay, so consider here I have monolithic application. Okay, this is not visible properly, right? Yeah, if you see here I have shipping service, I have inventory service, I have accounting service, and I have storefront UI, all these being part of one single var file. This is traditional application. An example, a traditional web application. If you see, all these are modules. Accounting service is a module, inventory service is a module, shipping service is a module, and a storefront UI. Okay, UI something, a front end. Okay, so when we implement a monolithic application, all the modules being of single var file, right, we'll create it as a var file and we deploy into Tomcat, and from browser we get request to Apache, maybe your front end HTTP server. From there you will receive request to your Tomcat. While using Apache Tomcat, it is clubbing of both Apache and Tomcat. Especially we need not to use any Apache. Okay, but yeah, so this is good pictorial representation, right? You can understand more. From browser, when I get request, Apache receive it and it will send it to your Tomcat. There you will have all the code, and you will have one database resource, one single database for all these modules. In simple words, this is the monolithic. What are the advantages with monolithic? Simple to develop, simple to test, simple to deploy. Scaling is not simple, but okay, let's use this. Scaling the entire application. Okay, in case if you, as it is deployed as a single application, if you apply scaling, it is applicable for the entire application. So it is easy to develop, it is easy to test also, it is easy to deploy also, because one single application, and you know where it is deployed. If you want to apply scaling and all, you can apply it. As you don't have so many applications, only one application you have, you can play with it. It is simple to develop, test, deploy and scale. Why I should go with microservices if it is simple? Again, as I said yesterday, right? As I said yesterday, depending on business, if you want to keep your business as soon as possible into the market, monolithic is not the suggestible. And if you want to apply scaling only to the particular modules, that is also not possible in monolithic. Okay, and maintenance will become, of course here also maintenance is easy as you have everything together, but from the business, if you see, they don't like it, because it is not faster than microservices application development and not really cloud friendly, not really cloud friendly. Instead, you doing everything, every module together into a one single application, right? So this is monolithic, right? So this is what monolithic, as modules we implement them. When you see microservices, architecture, as a services we will implement them. Microservices will implement each module as a service. Each module as a service we implement it. As a service we will implement it. Okay. So basic diagram I have here. Copy, paste. Okay, let me get more space. It is big picture. Okay, so in microservices, what is the advantage here? As I said yesterday, right? There are so many, but yeah, let's not go that much deep. Okay, so I have delivery service which is having delivery related information, order service which is having order related information, consumer service which is having consumer related information. Okay, and I have multiple development teams. Consumer development team will work on consumer module. So here I have consumer team, they will work on consumer service implementation. And I have delivery team, they will work on delivery service. And I have order service team, they will parallelly work on order service. So they will take care responsibilities. Okay, if there are any issues in order service, order team is specialized in that, they will take care of it. And if there are any issues in delivery, delivery team will take care. If there are any issues on consumer service, consumer team will take care. And if each service want to interact with another service, yes, they can make that communication. Order wants to talk with the delivery, or delivery wants to talk with consumer, or order wanted to take consumer information. Anything, right, is possible. Vice versa, we can communicate them. Or else if you don't want to direct communication, I don't want to touch one module with another module, okay, you can go your request via gateway also. Gateway will play very important key role in microservices. Very important gateways. Okay, so via gateway also I can able to communicate. order service wants to see delivery information, or delivery service wants to see order details, what a person is ordered. So via gateway also we can able to communicate it. We'll explain about gateway, okay, more in detail. So you can have independent applications, a smart applications, independent applications. You can implement them parallelly by many teams, and you can manage them. You can manage them easily, and we can use gateway for intercommunication. We can use a gateway for intercommunication. So this is a basic microservice architecture. This is very basic microservice architecture. Instead of implementing each and everything as a single application, you can break them into smaller functionalities and you can develop it. Okay, this is what microservice, in simple words, this is what microservice is. Okay, now the next pattern, we understand what is simple monolithic and what is microservice. Okay, now let's understand, right? Okay, what things will drive through implement microservices. Okay, what things will drive through implement microservices? Two things that are mentioning here: microservices architectural style that structures an application as a collection of services that are independent, deployable and loosely coupled. You need to remember these two principles. Independently deployable. Okay, each microservice should be independently deployable and loosely coupled. Independent deployable. Okay, now I have a microservice. Or I want to implement a microservice. How to implement it? I have large or huge requirements in Jira, right? I have so many requirements in Jira for so many modules. Something, a ticketing tool, there we have all the stories. I have so many stories I need to implement. There are hundreds of stories I have. So from these hundreds of stories, what should I pick up and how should I implement as a microservice? So keep it in a mind, whichever story you pick, if it is independent deployable, independently manageable, means if it doesn't have much dependencies with other stories. Okay, understand here, if your story doesn't having much dependencies with other stories. I don't have any dependence with other story. I have a user registration functionality which is more independent. User registration is the first point where we will get the user information, which is more independent. So independently we can manage, right? Examples of independent manageable user stories. Shall we Google it? Let me ask ChatGPT. Independent stories, examples which we can implement as a microservices. See, it is giving some examples on, I think, file storage notification for e-commerce. User authentication service which handles login logout functionality, payment gateway service which handles payments, product catalog service which maintains the store information, order management service which maintain all the order details, to send the notifications, emails, notification service, file storages. I want to store user reports or documents or images which are related to product. I want to store it into a blob somewhere. You have a storage system separately. Analytics services you can implement separately. See, you can take that as an example. You have stories for all of them here. Okay, I have stories for user authentication, or user login functionality, order management, so to create orders and manage the orders, notifications, you can create it as a separate service. Notification stories I have, which is mail notification, I have a requirement. Right, so as they mentioned, file storage, I want to store images, so file storage, one separate service I can implement. So when you have such requirements, right, you need to brainstorm, you need to understand, okay, which can be implemented it as a separate microservice. If you are a senior guy, you should be in a position to identify them. Okay, I think notification, sending emails looks like a not having any dependency with other modules. Let me implement it as a separate service. So whoever wants to send mails, they will use my microservice. They will make a REST call to my microservice so that I can able to accomplish their requirement. When you make them as a independent services, right, when you make them as independent services, you will be reducing lot of confusions, right? So you need not to reach out to someone else, and you need not to depend on someone else functionality. You can purely focus on your functionalities and you can deliver it. Parallelly, let's say I have 4 modules, I have 4 team members. If I assign user logging functionality to one member, order management, notification, file storage to each, they can parallelly work and deliver by the end of the sprint, so that it is easy to me deliver this project end of the day. So each module should be independent manageable. Okay, independently manageable, that is what this diagram is saying, what all things independently need to be managed. Small autonomous loosely coupled teams, a small team can work on it. Each service, right, when I say independently manageable, if I pick up one module out of it, order management, one microservice I want to design, order management microservice. Okay, one order management microservice I want to implement. So a small team can work on it, or an independent guy, if it is a small user story, one person or a team. Order management team will work on it. So you will have your own code repository. Nobody is going to disturb your repository. You will not see many push requests, many merges, no confusion, right? If you have a single repository for so many modules, lot of fight will be there, definitely. Everybody used to put their code, daily we need to get the latest, we need to check is our code is affected or not, again we should push our code. That's a lot of confusions it used to create. But if you have your own repository for your own functionality, happy, nobody is going to disturb you. Each service will have its own repository. right? Obviously, right? We will create one repository. If not available, a git or bitbucket works repository, like you know how to create it. Maybe in git, okay, we have GitHub here. So in GitHub, when you want a new repository, you can create it. New repository. So for each microservice you can create product service. I have create product service, order service, once it is created, you can share this repository with your team or whoever is working on order service, right? He can able to clone it. He can easily clone it using this git command. Then he can start working on it. He can create basic skeleton of Spring Boot project. You know how to create it, and you place your code in that repository and you can code it and deliver it. That's it, you are done. Each service is tested in a isolation by its own automated deployment pipeline. Generally microservices, nowhere we are deploying manually. We are using CI/CD to deploy it. So DevOps teams, by the time we complete our work and moving it to repository, let's say this work I started today, it will take next to 10 days or 20 days or 30 days to implement order management. So as soon as I start with this development, we will inform to the DevOps teams also, right? DevOps teams will involve creating your DevOps pipeline, providing you services, infrastructure, right? You may order anything. You may ask for a database instance. You may say, I need one database, create a database and provide me username, passwords. They provide you, infrastructure team, and they will create pipeline also by the time you done with your work. Once you move it to your repository, deployment pipeline will execute your test cases and all, sonar scanning, right? So they do configure in such a way. While creating our application, right, we need to properly achieve test percentage and no sonar issues. All that we need to ensure, so that in deployment pipeline, one more time they test our code, they execute all the test cases. If anything fails, pipeline will stop execution. So all that preconditions they can put on a deployment pipeline. If everything is passed, it will deploy into your server, whichever server they provide for your order service, right? A dedicated service you have, a dedicated service, a dedicated port you will have for your order management microservice. So there you are done. Your order service implementation is done. So when you want to implement a microservice from your user stories, it should be first independently manageable. Okay, the first point is independently manageable. And what is the next pattern? Loosely coupled. Loosely coupled, independent, manageable, and loosely coupled. Basic principles. Loosely coupled. So if you see one sequence diagram given, okay, so client is making request to order, general e-commerce, right, simple e-commerce application. Client making a request to order service making a request to consumer service. Okay, so order service itself calling to kitchen service and blah blah blah. So many services we have. Okay, yeah. So here if you see, order service is having dependencies with multiple services. I have an order service, it is dealing with consumer service, kitchen service, and some extra services. Reduce runtime coupling, design time coupling and development time velocity. Design time coupling, change customer service to reducing design time coupling, blah blah blah. Okay, so anything it can be. Okay, yeah. So runtime coupling, there are actually two different types of coupling. Loosely coupled means we know from Spring. Okay, we should not have much dependencies between services. Okay, which means while designing the services they should not have much interactions. Okay, they should not have, they can have minimal interactions, but they should not have much interactions. I have user service, login service, notification service, this many services I have. Let's say for every order related task, order service is having so many, okay, so many functionalities in it. So for every order I want to send mail, and only for order I want mailing service. I don't have anything for login or file storages. Okay, just imagine I have login service. For every login or sign up I want to send notification, or when order is placed only I want to send notification, and when a image is stored from inventory management or a video is stored I want to send a notification. So all services are having notification service dependency, so we can't duplicate this code everywhere. And this is not only for order management, so then we can decide that okay, I can create it as a separate application. And your service should not depend on this service always for all the functionalities. So in order management system I have 100 functionalities, all 100 functionalities needs that mailing service. So then this is bad idea to use separate microservice for order management. You better implement one more mailing service in order management itself, because when you create a separate microservice, I have 100 calls in the order management. The same 100 calls, if I try to redirect to notification service which is deployed in another server, there is unnecessary network communication will happen. Via network your call should go to another service, it should come back. Sometimes that ABC service or mail service, if it is down, unnecessarily order management also will get disturbed. Getting right? So if you have such a huge dependency across your functionalities, don't create it as a microservice. Instead you can club them together. But if you feel that it's okay, out of my 100 calls only 15 calls are having mail dependency or 10 calls are having mail dependency, then it's okay. Then it is okay to create it as a separate microservice and use it. That is what mentioning via loosely coupled pattern. Here. So what it is saying, runtime couple and availability. So there are two different types of couplings. Runtime coupling influences availability, design time coupling. Okay, so forget about design time coupling. Just see what is runtime coupling. Runtime coupling between services is the degree to which availability of one service is affected by the availability of another service, isn't it? That is what I am saying, right? In case if something is failed, notification service is failed, I have huge dependency on notification service. Obviously order service also will fail. I am placing lot of orders which are very important to my business. Because of notification service is down, a separate microservice that was down, so because of that downtime of notification service, my orders also not placing, so obviously you lost your business. Now you should not have such runtime coupling also. During runtime you should not send so many calls. If you have that, it's better to implement it under your service itself. Okay, it's degrade which availability of one operation implemented by one service is affected by the availability of another service. Runtime coupling if you have. So you need to reduce that runtime coupling. You need to reduce that runtime coupling. So for that, here he given an example. For example, imagine that create order system operation is implemented by an endpoint order service. The order service handles HTTP post by invoking other services, waiting for them to respond, and then send response to clients. So imagine I given user stories for services. In that services you have consumer service, kitchen service, okay, some other XYZ services you have. So you understand that, okay, independently I can deploy them. Consumer service I will implement separately, kitchen service I can implement separately, order service I can implement separately. I will deploy them. Okay, you can do that. But if you understand the dependency here, whenever a order request comes to order service, it need to approach definitely a consumer service or kitchen service. In this design, order service cannot respond post request until the order service responds to it. Runtime coupling to the other services, as a result the availability of create orders operation is reduced, since all the services must be available. See, I am placing a order that is first going to consumer service. Once I get the response, it is going to kitchen service. Once I get response from kitchen service, it is going to some other services. So what is happening here for the client? So when this client will get the final response, I have a order service, it posts to consumer service. Consumer service need to give response first properly. Again I need to make a call to kitchen service. I need to get 100% response from there and XYZ services. Once after all the services I'll get final response, then only I can say client whether it went success or failed. Do I need to really put that much dependency is the question here. If you put that much dependency here, you know, the success rate we can't ensure. All client operations may fail or few may success. So obviously it will degrade your application performance as well as degrade the application reliability also. We can't ensure that 100% your request will execute and it will be going success. So here again they proposed, in case if you have such a dependency, okay, you can make a order service and give response back saying that okay, your order is taken. Later you operate them, send a notification to the customer, okay, your order is placed. When you place order in Amazon or when you place order via Flipkart, Myntra or somewhere, you will see immediate response. It will say okay, your order is success. But really, is it finished all the operations in the background, informing to the delivery agent, informing into the, you know, other party about your order? That will immediately not happens. So your services still in the background it will execute, but for you as a customer they don't want to wait you. So when client asks for a product, it will say okay, your order is received, we'll take care about it. Then in the background it will make a call to consumer service and blah blah blah. Remaining all it will do on its own without waiting customer. Okay, still why I am there I didn't understand. Yeah, so independently manageable and loosely coupled. End of the day what I want to conclude here, your application should be loosely coupled, independently deployable and loosely coupled. Loosely coupled. you should not put a strict communication style. You should not put a strict communication style. Even in communication also, as he given, right, e-commerce is a perfect example. During communication also, don't say that I got a request, I will do everything, once everything is done only I will give success or failure response. Don't put such restrictions. If you do that, customer will not wait. He will definitely cancel the existing request and he will order the same product from another e-commerce. Okay, as you are independently implementing all these services, have a look into request pattern also. Okay, so have a look into request pattern. Try to make it as much as loosely coupled. Even your services also during coding, not only the request runtime or request pattern, even during development also, right? If you have huge dependencies, don't decouple them. Don't decouple them like a multiple microservices. Instead, right, create it as a single microservice. Okay, that is recommended. Okay, yeah, and other patterns. Okay, so these are the two important things. Okay, your microservice should be independently deployable and they should have loosely coupled in the sense they should not have dependencies. So all your independent services should be loosely coupled services, then only they will become independent. Okay, so independent, when it will become dependent or when it will become loosely coupled. If they are independent, your services are loosely coupled. If your services are loosely coupled, they are independent. Okay, so how you will understand? From your user stories only you need to understand that. From your user stories only you need to understand that. Okay, then only you can able to create it as a independent microservice. Then only you can create it as a independent microservice.